Hi everyone, this is Dr. Orkun Baycek, and today our focus will be on forecasting methods. So, when we talk about forecasting, what we mean really is that we look at past data and we use that past data to predict the future values. This could be for past sales, past demand, and we might be looking at these data values and then use them and use some techniques to predict the future values of the sales or demand values or whatever values we are interested in. Okay, so that's the main definition of forecasting that we are interested in. There might be different types of patterns that you might see in your data set. Let's say that you have a data set that includes your past sales from a number of years, okay? And then you plot a time series graph on Excel or whatever software you use. And in general, you might have different types of patterns, but in general, you might be seeing a pattern like this one on the left, which we call random variations. Okay, there's no specific patterns, it's kind of all over the place. The pattern is random. Okay, so this could be one thing that you might be seeing. Another pattern could be seasonality, the one on the right here. So the seasonality is basically you have certain time periods in which the values are increasing or decreasing, and then increasing, decreasing, increasing and decreasing, and so on. Okay, so you have this constant seasonality pattern like this one. So it goes up, down, goes up, and goes down, and so on. So if you see a pattern like this, you have seasonality in your data. And the last one of the most common ones is a trend and random variation. So basically what you see here is you still have some random variations kind of occasionally going up and down, but at the same time you have a trend, right? If you look at the general flow, what we see is an increasing trend. So you have an increasing trend in this data set. So we are going to see what kind of approaches, what kind of forecasting methods can predict the future values. Okay, any forecast will have an error. Okay, it's usually reasonable to assume that your forecast will have some sort of an error. And what I mean by error is that you may not be able to forecast or predict the future value with 100% accuracy, okay? So we are going to measure the forecast accuracy, and there are some measures such as mean absolute deviation, or we are going to call MAD in short. You might be using mean squared errors, MSE, or you might be using cumulative error. There are other measures, but these are the ones that we will focus, all right? In this video, my focus will be on the random variations only. Okay, so when you plot your time series graph, you are seeing a random variation in your data set. Typically, the most commonly used methods are simple moving averages, weighted moving averages, which is a version of the first one, or the first one is the version of the second one, in other words, and simple exponential smoothing methods. Okay, so these are the commonly used approaches when you have random patterns in your data set. I'm going to spend time on simple moving averages and weighted moving averages in this video, but there will be a separate video on the simple exponential smoothing after this particular video. All right, so let's look into an example. So I have a data set here, and in this data set I have 12 time periods for which I know the actual sales values. Okay, so what I mean is, let's say that I looked at the last 12 months and I listed how many items we sold. Okay, so the first month, for example, we sold 30 items. In the second one, we sold 28, and so on. Okay, so this is the general idea. So this data set is actually the graph on the left. So you have random variations. Okay, so this graph belongs to this data set. So I have random variations, which means that I can use simple exponential smoothing, weighted moving averages, or simple moving averages. Okay, so like I said, we are going to look at moving averages and weighted moving averages. So The moving averages technique will always include a number of time periods that you will use in the calculation. And what I mean is the question will tell you, or you're going to decide that you're going to use K period moving averages. Okay, so that K may be a different letter depending on the textbook or depending on the lecture. But usually, for example, 3-month moving averages, 5-year moving averages, 6-year moving averages, and so on. Okay, so you will always see a value, a number like that. And if I say that I'm calculating K period moving averages forecast, the way to calculate that value is to take the sum of the actual values, okay, the actual values that I already have in the last K time periods and divide the sum by K, okay, whatever that K is. And we are going to see this in our example in just a little bit, okay, so but this is our general formula which we will use in our calculations. So here is my question, and the question says you have a data set that summarizes the sales for the last 12 months, and part A is asking us to forecast the sales in period 13 using a 3-period or 3-month, because my periods are actually months, moving averages technique. Okay, so I have my K value, K is 3, okay, and I'm trying to find the forecasted sales in period 13. Okay, so here's what I'm going to do. So if I am calculating a 3-period moving averages forecast, what I'm going to do is I'm going to go to the next time period. So K is 3, I'm going to go to period K plus 1, okay? In this case, K plus 1 is period 4. And what I'm going to do is I'm going to take the sum of the last 3 sales amounts, okay? So I'm going to take the sum of the last 3 sales. If you look at my formula, sum of the actual values in the last K periods. And K is 3, so I take the sum of the values in the last 3 time periods, which is in this function. And I'm going to divide that sum by K. K is 3, therefore I am dividing the sum by 3. Okay? And that value is equal to 30.3. So I can repeat the same, use the sum function, and look at the last 3 time periods. In this case, I am looking at period 2, 3, and 4, and their sum will be divided by 3. Okay? So let's look at these 2 functions, the 2 functions that I used. If you look at the first part, the numerator, what you see is the first part, B2 increased to B3, and the second part, B4 increased to B5. So in these situations, what we do is essentially, you don't need to do this manually, but you can go to the bottom right of the first function you typed in and drag it all the way down and calculate your forecast values automatically. Okay, and the whole reason is, again, since your values are increasing one by one, if you look at these, it goes B2, B3, B4, B5, and so on. So you don't need to do this manually, and you can use Excel to calculate them automatically. So the reason why I went all the way down to period 13 is that I'm trying to forecast the sales in period 13, okay? And I don't know the actual value, but I have a forecast for period 13, okay? So the answer to question part A is 31, which is the forecast for year 13, okay? Let's say that the question is asking, what is the forecast using simple moving averages technique in period 6? Your answer would be 34.6, okay? It can ask, what is the forecast in year 5? The answer is 29.3. And if you remember, earlier in this video, I mentioned something called forecast accuracy. So the accuracy can be measured by the difference between the actual and the forecasted. So if you look at, for example, period 5, the actual sales was 44, our forecast is 29. So you have about 14 units of difference there, okay? So you forecasted it as a lower value than it is. And if you look at the sixth period, it was actually 21, but your forecast is 34. So your forecast is higher than the actual in this case, okay? So in a separate video, we are going to look at the forecast accuracy measures, and I will put the link to that video in this video as well, so that we can see which forecasting methods can beat another one and so on, okay? So the answer to part A is 31. Question B is asking us to forecast the sales in period 13 using a weighted moving averages technique in which the weight of sales in the most recent period is 3, and then the weight in the next most recent period is 2, and the weight of the least recent period is 1. Okay, so this is a different approach. What this says is focus more on the most recent year and then decrease your focus a little more as you go away from the most recent year. So your most recent year has more impact on your forecast, and the next one has a little less, and the next one has a little less, and so on. Okay, so that is the idea. So next, I'm going to put these weights into my Excel template. Okay, so I have a template at the bottom here. I have the weights and I have the time period. So I'm going to add these weights into my template. What is the weight for the most recent time period? The answer is 3, right? So period 3 is going to be 3. The next most recent is 2. And the least recent is 1. Okay, so when I calculate these weighted moving averages, the most recent one has a weight of 3, the next one has 2, and the last one has 1. So let's calculate the weighted moving averages for starting from period 4. If I am at period 4, what is the most recent period before period 4? That answer is going to be period 3, right? The most recent before my current period is period 3. So the calculation will include the product of the weight and the actual sales value plus the weight of the next most recent time period times the sales in the next most recent time period plus the weight of the last times the sales in the least recent time period. Okay, so I'm going to sum these up. So I put them in parentheses. As you can see, this summation at the end will be in parentheses, and I'm going to divide the sum by the sum of the weights. Okay, so I find that sum and I divide it by the sum of the weights. Okay, so here's a trick. I don't want to do this over and over again for the upcoming time periods. What I'm going to do is, since these weights will show up in all of the upcoming time periods, I'm going to put dollar signs around D20, C20, and B20 in the numerator, as well as the denominator, because again, they will show up in all of the upcoming calculations. And to save time, I'm going to put dollar signs and calculate the first one, and all I need to do next is to drag this function all the way down to period 13, and I have my forecast for period 13, which is 30.67. Okay, so the answer to that question is 30.67. If the question were to ask, using this weighted moving averages technique, what is the forecast in year 9? So year 9, the answer is 29.5. What is the forecast in year 6? The answer is 36.5. Okay? So, as I said earlier, the simple moving averages technique is a special version of the weighted moving averages technique. And what I mean by that is basically the simple moving averages technique is a type of a weighted moving averages technique in which all the weights are equal to each other. Okay? So what I mean is, let's say that all the weights are equal to each other, let's say this is 1 instead of 2, and this is 1 instead of 3, let's see what happens. What happened is all of these forecasts are equal to the simple moving averages forecasts. Okay, so again, the weighted moving averages technique and simple moving averages technique are closely related to each other. The simple moving averages technique is a weighted moving averages technique in which all the weights are equal to each other. Okay, if the weights are all 1, the weighted moving averages will give you the same forecast as the simple moving averages. Okay, so that is the relationship between them. So if you have the general understanding of the weighted moving averages, it should be straightforward to calculate the simple moving averages forecasts. All right, so this will conclude this video. Thank you so much for watching, and I will see you in the next one.